Hello everyone, today we're going to demo the way we process NetCDF files in another way. In last demo, we processed NetCDF by Spark. And in this video, we're going to using the other way. We're going to process NetCDF files by DataFibers, which is a Kappa architecture of a big data enterprise data bus. We build a NetCDF connector to extract data from the S3. Then the data is extracted and injected to the DataFibers. So once data arrived in the DataFibers, so you can actually route the data to any destination, like relational database, like MongoDB, like Hadoop, Hive, and other MySQL as well. And in addition, since the data is already in the bus, so you can perform inter-bus transformation, like byte transformation using Spark SQL, or using the stream transformation like Flink SQL. So all the data in the bus is in the format of arrow, so that we have a binary data format, so it's more compatible, and also it fully supports schema evolution. And right now, the DataFibers is basically leverage Apache Kafka, Spark, and Flink. And also it can support AWS Kinesis and Pulsar. Variety of data connectors and sync available right now. We will show the demos right now. So first, we'll see this website is DataFibers website, and here you can find a lot of information about DataFibers. And the address is www.datafibers.com. And also here, this is the DataFibers GitHub community. So here you can find a bunch of GitHub repository related to DataFibers. And data fiber connector we just mentioned to read a NetCDF file is here. It's in the DF certified connector repository is here. So you just added this recently. So now let's see how to run the demo. First, we're going to log in the demo machine, which is EC2 instance. Let me log out first. So I log in the machine. Because this machine is already installed DataFibers, so there's a bunch of command provided by the DataFibers. So most frequently used command is called DFOBS. So when we type DFOBS, it gives you a simple hub to tell you what kind of other command you can use by leverage this DFOBS. So first we'll check the basic installation. We set the DFOBS home to the DF folder. So it has a bin, config, lib, and repository folders. And in the lab folder, we have a bunch of library we needed. These are basically the connector lab and the core DataFibers service jar. And in the bin folder, there are a bunch of commonly used script. Now let's start the DataFibers. And DataFibers also relies on the other tools. So all these tools should be configured in the OPT place. Let's tools. So here is the bunch of tools we're using. DataFibers leverage to make big data processing. For example, we'll use Kafka, which is actually a Confluent version, and Flink, and Hadoop, and Hive, and Spark, and Levi for Spark Gateway. And also we could use Grafana. So because we have a streaming, if we want to visualize the streaming, it's better to use Grafana, this kind of tools. So now let's start the data fibers. Usually we'll do a DFOBS format. So this command actually do a clean up. You can see it clean up all the legacy data and formatted Hadoop. So we have a brand new environment. Then we'll see start max. This max parameter will actually start all the available data fiber services and support features. So let's start it. So from this command output, you can see DataFibers actually first will start Hadoop, including the data node and the name node. Then it will start the Hive, including two services, metadata store service and health server 2, as well as Apache Zookeeper, Kafka server, and also the schema registry. Also, actually, all these three services is part of Confluence. And also we need Kafka Connect to as a framework to get data and sync data. Then we'll start see Apache Flink and Apache Spark for both streaming SQL and batch SQL, as well as Apache Levi for the gateway of Spark. At the end of a startup, we are waiting for the Kafka Connect because this service actually take a little bit longer. So probably after 10 seconds, we'll have the service ready. So then we can look at our UI and do further operations. You see here, we see the data fiber data service is started. So we can just go for the web UI. The data fiber service web UI actually have its main page in the 8888. Let's see. Sorry, not 888. Let me see. What's the port number? Let me check the port numbers. 8,000. We'll go for the 8,000 first. So this is the excuse me, the data fibers main page. And in this page, we have four important areas. The first area is a web admin console. This is mainly the application console. Usually, we use this console quite often. So there, we are going to demonstrate how to create connectors, create a sync, and create a transform. And the other part is our API document. So in this API document, you can see a list of REST service backend by the Vertex server, and you can do what kind of operation on the data fibers. And also we provide a complete guideline, which is still in progress, but it usually give you a general idea of this whole project and how to set it up and any common issues. And in the next part is our GitHub code basis. So let's go to the web admin console. Okay, here is the DataFibers web admin console. So here in the left side, you can see a bunch of sub-menus. The dashboard tells you what are the currently available tasks in the DataFibers. And DataFibers have two components. One is called Connect. The other is called Transform. It's very easy to understand that Connect is used to bring data in the data fibers or export data from the data fibers. To bring in data, usually we call it a source. And to extract data, from the fibers to the other external system, we usually call this connector called a sink. So most time we call it the source of sink connectors. DataFibers provide a variety of connectors. Actually, is compatible with the Kafka Connect. For example, we support to get data from the S3 and extract the NetCDF files, and we support get data from the relational database, and also sync data to the relational database. And we also support sourcing data from regular file or arrow files, and also from the API. There is a demo connector to connect the Yahoo API to get stock information. And for sync, we support sync to the different kinds of relational database, to sync data to the Hadoop Hive, and also to sync data to the MongoDB, and so on. Another important component is called transform. The transform is very easy to understand, is that we want to change data. Here, we basically perform data transformation on the data fibers or on the bus. The transform can either be a streaming transform, which is in real time, or it could be a batch transform. It's like a mini batch. There are two engines support right now. So one is a Flink. Basically, we support to use Flink SQL to read one topic from the data bus, DataFibers, and dump the result in real time to another topic, also in the DataFibers. The other transformation is Spark. We use Spark SQL to read the data from the one of the sink, for example, the Hive tables. Then we'll get a result and streaming it back to the queue. It's like from the batch processing to the stream processing. Because once the data is streaming back to the queue or DataFibers, so you can continue route it to different destinations or do further on-queue real-time transformations. Except these two important parts, we have another important part called the topic. The topic here is basically a schema registry concept. It's actually a Kafka topic. By using topic, we can easily manage the data file schema, which is in the arrow format. And there are also other information like data models. Here we actually can be used to training our machine learning models on the data fibers. And the history shows what kind of arrow file to process, especially for the file connectors. For the logging information, here we actually collect all the data fibers log. You can see here it's in the JSON format, so it's the application log. And for the configuration is basically this configuration for this interface. So now let's demo to read NetCDF files. According to our architecture, we are first reading NetCDF files, and finally we dump it to the MySQL. Let's see how easily we can achieve this using DataFibers. So first we see we can actually create connectors. For here, it's like a widget or guideline for people want to create new connectors. So you can give the number of the sequence for this connector and give the connector name and simple description. And you can choose to connector either a source, which is brings data. This is we are going to demo first. And we choose the task type. Here we have three supported. So the UK Meet API is the target source. We'll need to bring the or download the open the NetCDF files. And then in the next part, we do a little bit of configuration for this connector. We usually can select what kind of data topic you want to write to data. And you want to give the file name prefix. By using this prefix, we're matching the the target file we want to download. And also we give this curve variable we're going to extract from the files, as well as the coordinate system, because some file is in the coordinate x or y, or sometimes it is in the latitude or longitude. And for the global, you see the file is in the latitude or longitude, and for the UK, it's usually use the coordinate y or x. Then we give the Amazon SQL as URL because we actually get notified from the SQL message when the new file is uploaded. And then we can specify proper AWS SQL region, the proper S3 bucket name, and S3 regions. And also we need to provide a temporary location. Actually, this is a default location because the application will create. And also we specify the interval for each pool from the DataFibers to the source. Because we already have a connector created before, so we don't need to create this one. We will just need to restart it. You can see here for each connector here is created before. The current status is lost, is not, they are not active. So this button here is actually a shortcut for restart the connectors. So let's find the proper source connector. Okay, the source connector. We will use this UK surface area pressure. So let's edit it. So see, we already have the information populated, and we have the settings properly set here. The data will actually write to the topic called the surface air pressure here. So once we start this connector, you will see a new topic created here. Here, from this topic, you can see what's the schema for this data. Okay. Okay, now let's restart this connector. Let's go back. You can see once we restarted, the status becomes to the restart. And it will take a couple of seconds. You will see the current status is become the running. Okay, become the running. So we can go for it into details. We see, okay, everything is fine, and see the status is also running. And also we go back to the topic. In this topic, we can see this schema actually created automatically. It will tell you the data structure we created for this NetCDF files. Actually, it has a bunch of columns like file prefix, file name, file creation date, and some coordinations, and the curve variable we're going to extract here. So this is the topic. So once the data arrived, actually you can click this data, and it calls the API to fetch data for you. But also on the other hand, you can just use the command line of the Kafka to check if the data is coming. So let's see if the data is coming. Let's go back to the command line here. Before that, let's first copy the topic. Copy the topic like this. Let's give a parameter from beginning. So we'll start to consume that. You can see is a bunch of data is actually already write to the DataFibers, or say the Kafka. So from command line consumer, we can get the data here. So the data is actually being ingested or extracted to the DataFibers. So next step, we are going to use other connectors to dump this data to different locations. So first, let's see, we'll dump it to the MySQL database to finish our demo target first. So we'll find actually previously created a sync connector somewhere. Okay, here is it. For this connector, you can see we choose the task type as the sync JDBC. It's basically using a JDBC driver to dump the data to different database. And let's check the setting. For the settings, we need to specify what is the topic, and give the proper the JDBC URL like database name, and also you can specify auto create table or not, and give the batch set. And also, if we go back to the creation, you can see when we choose sync, we choose the JDBC. Go to setting. We can also choose which topic to select, right? When we create, there is actually a guide to select which topic to start. Before we start this sync, let's go back to the MySQL database first. See, we already have this table created. Let's drop it first. So there's no such table, right? Surface error pressure. Then let's using this MySQL sync. MySQL this. So double check surface error. Okay. Okay, let's restart. JDBC sync connector a little bit slow, so we'll need to wait a little bit longer. See, it is already appear in this UI. When we try to remember the previously demonstration using the Spark processing, when we run the application, actually take a little bit longer time to see data in the database. Because the batch size is a little bit bigger, but here we see, let's see how fast we got data in the MySQL database. Okay. Now let's sort tables. See, we already have this data. Then let's select something from it. Alright, see, the data is already populated. And then let's see if it's really in real time. Let's check the row count. Okay, it's around 356,000. See, you see this number is keep changing all the time. It's keep changing all the time. So it's meaning the data is actually write to the database in real time, almost there. All right, so at this time we basically finish our demo to bring data, extract data, and dump the data to the MySQL database. So once data is in the MySQL database, you can use other BI tools like Quick Insight, Tableau, or other BI tool to create a visualization or BI report. And we also want to do some further demos. One demo I want to demonstrate is that the connector, we can easily control it. For example, we can just stop it. Once we stop it, actually the connector will stop bringing data to the queue. I'll easily control the traffic flow with these features. Right. The other thing we can demo is we want to demo another thing that is called Hadoop Hive Sync. It's very easy to bring data to different destinations. For example, sometimes we have real-time data, and we want to keep it in the Hadoop for history analysis. So we want to dump all data to the Hadoop and of course have tables. Then we can use like a sync of Hive. So here we already created a connector called sync Hive surface area repressor. So you click it. You can see in this connector sync, we specify which topic we want to read data from DataFibers. Then we just give the proper HDF as URL. That's all. The table name is actually in Hive is exactly same to the topic name. So we can just restart it. Because in our message queue, we already have a lot of data in topic. So we'll see this data goes to the Hadoop Hive very quickly. Okay, we can see this. Connector sync is running, and let's go back to the console to see what's going on in the Hadoop. We use the Hive command to go to the Hive. And let's show tables. All right, we see this table is being created. Let's see. Limit 5. Okay. Let's see how many rows it has. It will take some time because when I do a count, will actually run MapReduce. Let's see to see if it's going to change this number. See, this number is keeping changing, so we know that the data is keep writing to the Hadoop. So once all the data in the topic are right, it will stop because we already stopped the connector. But once we resume the connector, the data will continue coming to the DataFibers. So here we demo actually 3 connector ID. One is the source open NetCDF files, and we demo 2 sync. One is to MySQL database. The other is to demo sync Hadoop database. And we see the topic here. We have the one topic. And at the end of our demo, we'll just demo a little bit our DataFibers transformations. We'll try to demonstrate how we're going to do a real-time transformation from one topic to other topics. Now here we already created one. It's called the Flink data transformations. If we go back, go to the widget, you can see whenever we create a new transformation, there's a different type of transformation supported. One is for example, we support the stream SQL based using the Flink, batch SQL using the Spark SQL, and streaming API, batch API is basically we can define the API call directly or using the UDL directly. And also in the future, we're going to support our online machine learning model training and also deploy our machine learning model on the streams. But now let's go back to the Flink online real-time transformation. So here we already created. Let's see the properties. So basically in this property, we want to first specify what is the source topic we're going to read the data. So it's the surface air pressure. Let's check if we have this topic. Yeah, we have this topic, surface air pressure. And then second, we want to create another topic that we want to output our data to another topic. We call this, we append a trans in front of this and also the Flink. And we need to give a customer ID. Actually, this is optional. It's used to subscribe from the DataFibers. And we give like a partition columns for better performance to sync data to the Flink. And the last, is the most important part. We can specify the real-time streaming transformation logic, and this logic is not, and it doesn't has to be in any coding languages like Java, Scala. It's just the plain standard SQL. Actually, it's a streaming SQL supported. You can see in this SQL, it's a little bit complex in the one we read before. We actually select the biggest error pressure by group of file names, project Y and project X, from the topic. From the topic is called surface air pressure, and we see what's the maximum air pressure is it for each coordination for each file, and we want to write this result to the another topic called transflink air pressure, right? Then we'll save it. We'll save. Let's remove this. Okay. Once we submit it, you can see this job will take some time to start it, and we'll see this job going to running. Here we can see the job is running. Let's check the topic, and we can see another topic is created called the transform flink air pressure. In this topic, let's check each schema. Based on the SQL we just read, we have our schema very clearly here. It's just 4 columns. And further, actually, you can just create another sync connector and put this topic to either MongoDB or MySQL database or Hive as well, right? But here, we don't want to do it anymore because we already demoed that. We just have a simple check to see if we already got the data. And let's copy this topic here, and we can just, for simple, it's checked from the command line. Let's check from the command line. And remember, we have only 4 columns. Let's see. Okay. Start it. Let's wait a little bit because just that we paused the connector. So let's wait a little bit so that we can see the data will come through. So because the Flink job is running, actually this is a Flink web console. You can see, we can see in this Flink web console the job is running, and here is all the details here. And in the meantime, we can also check the log files for the either DataFibers or for the Kafka Connect. From here, you can see the Kafka Connect already put the data here, and then we'll start to see write data to the Hadoop. Here you can see where it's going to write, right? Surface air pressure 01. Let's see, surface air pressure 01. Surface air pressure 01. Surface air pressure 01. Okay, here we see our data. Let's stop it a little bit. You see here, we call the surface air pressure max. It's a max value for the air pressure, and we have our file names, right? Our new file names, and have our coordinates. So here we can see in our message queue, it will actually do a real-time transformation. Basically, here is our demo, and also we can see that DataFibers also support the Spark, and you can do a Spark batch SQL from the queue. Let's very quickly do something. We just write a simple Spark SQL and we run the result. Let's give the file name. From the transformation of batch, we can actually using Spark SQL to query the database in the Hive. Let's just get a very simple demonstration to get a file name from Spark. And then we go back. So actually, DataFibers will launch Spark SQL through the UI and query the database in the Hive. Let's wait for a little bit. Oh, okay, it's finished. So once finished, we can see the result. See the result here. You can see. We only saw the top 20 rows. So here's the file name. And based on this, we gather the query result, and also we have option to pull this query result back to the queue, and to make our connection from the batch to the stream. And I think that's our all for today for our demo. And thank you for your time. It's take a little bit longer, and this is the end of the demo. Thank you.